Good morning. In this class, we see about second step of the general FEA steps. Okay, that is called as how to give a numbers and node of the element. Okay, so last class we see about how the discretization structure is like a one-dimensional element or two-dimensional element or three-dimensional element or four-dimensional. That's like a axis symmetric element. We have to see the detail about these types of topic. Okay, and today class we discussing about numbering and node. Okay, so first of all, if you have any element, you have to any discretization like a one-dimensional problem or two-dimensional problem or three-dimensional problem or axis symmetry, you have to discretizations. Okay, the discretization meaning purpose is called as you have to consider the small element. Okay, so for example, here you have to consider the numbers and node of element is based upon the divisions process. Okay, so for example, here I have to consider figure number 2 figure I have to consider. Okay, what is called as a long say numbering process and a short say numbering process. Okay, so long say numbering process I have to divide into 5 and 3. Okay, so that 5 into 3 is called like a 15. Okay, there is a number of element we have a 15 and each node, that is each corner having a nodes. It's like a rectangle, so each triangle having a four side. Okay, for example, I taking one, so one I have 1, 2 and 5, 6. Something is number is element is there. Okay, other 5 and 10. Okay, so here I have to taking for the maximum number is like a 15 and the minimum number is 3. Okay, if you are differentiating this element, I got in certain answer. Okay, and also for the short numbering process, the short numbering process here I have to consider the any number. For example, 9, 11, 13 and 14 and 15 I have to consider. Okay, the maximum axial number is 14 and the minimum number of node is for 9. So the difference between the 5. So these are the basic steps to give the numbers and node. Okay, and also the next one is selection of displacement function. So the displacement function is based upon your process of calculation. So either you have to taking for the linear approximation method or quadrilateral approximation method. Both having a different types of method. For example, can be involving the choosing the displacement function within the each element. For example, the polynomial of the linear or quadratic or cube is a form as a frequently and used as a displacement function because they are simple to work within the finite element formulations. For example, here I have taken the x-axis or y-axis I have considered as a certain function. So this function is not exact mapping with solution, not exact mapping with solution. For example, the S-bend curve is represented as a exact solution, but the pi of x, they have to linearly, there is a cut in the S bend. Okay, so that is called as my linear approximation. That is the x-axis I have taken for the element. Okay, and is represented as a x. And for the quadratic approximation solution, in a unique quadratic approximation solution, the corresponding of the S bend is mapping with the exact solution of pi. So the phi of x is equal to a0 plus a1x. Here a0 plus a1x plus a2 x square. So here there is a polynomial quadratic equation in terms of power, but in a linear there is no power value, only the constant and the x power value is 1. Okay, so these are the polynomial types can be interpolations of the functions or modify using the following reasons. So one is for understanding the easy formulations. Okay, understanding the easy formulations of the computing the finite element equation, and is easy to perform the different or integrations. Okay, so these are the selections of the displacement function. And the next one is define the material behavior. So based upon your property, you have to understand what is the property you can give the element. For example, I have to give the element one is aluminum and the element two is a copper. Okay, so that the strain displacement or stress strain relationship are necessary for the deriving the equations for the finite element equations. So this is the simple formation of the strain displacement. Okay, the strain displacement function. We have to deal with the certain formula in unit 4. What is the meaning of strain displacement relationship? Okay, now we have to consider for the simple consideration, that is a E is equal to du by dx. Okay, that is a strain is this with respect to the displacement, change in displacement by change in distance. That is a representation of du by dx. Okay, so here the u is represented as a displacement field variable along with the x direction. That is a E is represented as a strain. Okay, this is the called as a strain displacement relationship. Okay, that is a deal with we have to deal with for define the material behavior. The stress strain relationship is given by sigma is equal to E into E. The sigma is called as a stress in a x-axis. E is called as a Young's modulus and modulus of elasticity. It's both the same value. So it having a certain unit that is called as Newton per meter square, and the sigma is having a same Newton per meter square. The strain having a no SI unit for it. Okay, so this is the behavior, or this is the relationship between strain and displacement, or stress strain relationship. This is called as the finite element equation for derivations. Thank you.